So first off, let's now go to our slides. So focus muna tayo sa slides. Later tayo magsusulat sa ating board. Okay? So our topic today is acid, bases, and an introduction to organic mechanisms. So next slide. Yung discussion natin today, hinati namin into four parts, which mamaya makikita nyo din naman. First is acid definitions. Yan yung pinakasimula or pinaka-basic na part of organic chemistry. Then next is the factors affecting acidity and basicity, as well as structural prediction of the relative acid and base strength. And lastly, an introduction to the organic mechanisms. So next slide. So from our high school classes, nalaman natin ng pinakasimpleng definition ng acid ay in terms of Bronsted-Lowry. So, ano ba yung Bronsted-Lowry acid and bases? So, first off, naglagay lang ako dito ng simple para matandaan nyo. Acid is a proton donor. Meanwhile, a base is a proton acceptor. So, what do we mean by that? So, in terms of Bronsted-Lowry acid and bases, yung acid natin, lagi lang siya namimigay ng H plus or hydrogen plus ions. And at the same time, kung base naman, ina-accept lang niya, binibigay ng acid natin na hydrogen plus ions. So, in terms of organic chemistry, ang pinaka-ginagamit natin na definition of acid and bases ay yung Bronsted-Lowry acid and bases. Kasi, una, daming involved na hydrogen sa ating organic chemistry. So, with that, ito yung pinaka-basic na dapat maintindihan ninyo. Acid is again a proton donor, and base is a proton acceptor. Okay? So next slide. So what do we mean by proton donor and proton acceptor exactly? So here in your screen, you can see an example of an acid and base reaction. HCl or hydrochloric acid and water yung base natin. HCl is actually yung acid na nakikita natin sa katawan ng tao. And water ay marami din sa ating katawan yan. So, essentially, may chemical reaction tayo nangyayari every now and then. But, to explain that in terms of acid and bases, let us focus on the red-colored hydrogen atom. So, the acid here is HCl. As you can see, naka-color red yung proton na pwede niyang i-donate. Again, acid in Bronsted-Lowry definition donates the proton. And meanwhile, the base in the Bronsted-Lowry definition accepts the donated proton. So if in this case, titignan nyo muna yung left side of the reaction, kinukuha ni base, yung natatandaan nyo, kinukuha ni base yung proton ng acid na willing siyang i-donate. Okay? So ang nangyayari, nagkakaroon ngayon ng H plus yung water natin. Yan na yung nakakategorize natin na acid. Na conjugate acid ng ating water. Meanwhile, yung conjugate base naman ng chlorine, HCl, ay yung chlorine ion natin. So in that case, again, what you need to remember in acid-base reactions is Bronsted-Lowry definition na acid, again, donates protons na tinatanggap naman ni base. So pag nagkaroon ng acid and base reaction, dapat merong mapoprotonate, merong madedeprotonate. Okay? So that's the most basic concept of organic chemistry. So next slide. So here we have an example. Ang question natin, what is the conjugate base and acid? So in this case, we have here HCl and H2O. Yung nakita natin sa example kanina. Ang acid ay yung HCl. Bakit? Kasi mas willing siyang i-donate yung hydrogen atom niya. I-discuss later yung mga factors affecting paano nga ba nakakapag-donate yung mga acid. Pero in this case, ang kailangan nyo muna tandaan ay sino yung acid sa kanilang dalawa based sa chemical equation. So dito sa una, number 1, you have HCl plus H2O. Ang acid sa una ay yung HCl. Kasi dun sa right side of the equation, nakikita nyo, ang nagkakaroon ng proton or hydrogen atom ay yung H2O natin. So, siya yung base. Again, proton donor ay acid and proton acceptor ay base. For number 2 naman, we have here also the base. You have your negatively charged oxygen atom and it abstracts a proton from water. hence it produces an alcohol do sa right side of the equation. So in this case, kung kanina ang water natin ay nag-act sa base, this case naman nag-act yung water natin as an acid. So, natatransfer yung isang proton niya dun sa negatively charged na base. Nakikita niyo dyan sa screen niyo yung negatively charged na base. At dun sa right side niya, makikita niyo yung conjugate acid nung ating initial na base. If that's the case, the acid in this reaction is water. Ang tatandaan niyo lang again sa mga ganitong mga questions when you encounter them, saan napupunta yung proton? Kung nanggaling una dun sa HCl, siya yung acid. Tapos saan siya nag-landing? Dun sa water natin. Ibig sabihin, yung water natin yung base. Ganun lang siya ka-basic. Kung saan lang napupunta yung proton. Okay? Next slide. And as you can see from the example, let's pause for a bit. Water is amphoteric. It means it can act as an acid or as a base. Sa previous slide natin, nakita natin una, nag-act yung water as a base. Kinuha niya yung proton ng hydrochloric acid, HCl. Meanwhile, sa number 2, kinuha naman siya ng proton ng isang negatively charged na oxygen atom. So if that's the case, water is therefore noted to be amphoteric or it can act as an acid or a base. Depende na lang sa given system ng ating chemical reaction. So tatandaan nyo in terms of water, hindi lang siya base, the acid din siya. Okay? So next slide. So let's now move on naman sa Lewis acid and bases. Ano nga ba yung pagkakaiba niya sa Bronsted-Lowry acid and bases? So for Lewis acid, it is defined as an acid is an electron pair acceptor. And an electron, yung base naman, electron pair donor. Ano pagkakaiba niyan? Bakit pa kailangan ng Lewis acid and bases? Essentially, ang Lewis acid and bases kasi, mas wide yung definition niya. Meanwhile, yung sa Bronsted-Lowry natin, restricted lang siya sa hydrogen transfer. Kung sino nagdo-donate at sino yung nag-accept ng hydrogen. Meanwhile, for Lewis acids, ang definition nito ay mas wide kasi ang kinakategorize natin dito, sino ba yung nag-accept ng electron pair? What do you mean by electron pair? It is yung tinatawag nating lone pair in your general chemistry. So, for Lewis acid, tatandaan nyo lang, ang electron pair acceptor ay acid AABB. So, base is a donor, BB, and A is an acid is an acceptor. So, AA siya. AABB. Okay? So, that's the Lewis acid definition naman ng acid and bases. Next slide. But paano nga siya nagdo-donate? Paano nga ba nagkakaroon naman ng chemical reaction yan? I-discuss namin siya later, but let's now give you an overview on the next slide. So, for Lewis acid and bases, may kita nyo, meron tayong tinatawag na flow of electrons. Huwag muna kayo ma-overwhelm. Ang una nyo titignan dito, yung color red na proton. Na kanino yung acid? Or sino yung acid dito? Yung hydrochloric acid. Kasi nasa kanya yung red na proton. Or kaya siya yung mas willing mag-donate ng proton. So yung base, ang sabi natin kanina, kukunin niya yung electron pair. Kukunin niya yung proton from the acid. In this case, makikita mo na bibilangin mo muna electrons ng nasa left side. We have here 2, 4, 6 ng chlorine. Ilan yung electrons ng chlorine na lone pair dyan? We have here 2, 4, 6 yung sa left side. Ngayon, pag nag-react siya, titignan nyo naman yung nandun sa right side. Ilan na yung lone pair ng electrons? Ilan yung lone pair ng electrons? 2, 4, 6, 8. 8 electrons na. Nadagdagan ba siya or nabawasan siya? So, makikita natin na nadagdagan yung chlorine natin. So, nag-accept siya ng electron pair. Okay? So, when you're dealing with Lewis acids naman, titignan nyo lang, guys, kung sino yung nadadagdagan ng electrons. Kung sino yung nadadagdagan ng electron, siya yung acid. Sino naman yung nag-accept or nagdo-donate ng electron na yon, siya naman yung base. Okay? So nakikita nyo actually na para papaisip kayo, nasan yung pagkakaiba ng Bronson Lorry and Lewis acid. Essentially, in this example, halos same lang siya. Iba lang siya ng pagkaka-define. Pero in other cases, merong mga Lewis acid na hindi mo makakategorize as a Bronson Lorry acid such as FeCl3 or FeCl3. So yun yung isang example ng Lewis acid pero hindi siya Bronsted Lorry acid. So in this case, tatandaan niyo lang again, kung sino tumatanggap ng electron pair, siya yung acid and sino nag-donate, siya yung base. Okay, next slide. So again, how do we simply explain everything? Electron flows from region of high to low electron density. Kung familiar kayo sa concept ng chemical gradient, yung mga nakikita natin sa mga biological systems natin, lahat ng mga bagay ay nagpo-flow from high to low. Ibig sabihin, kung mataas masyado yung concentration ng isang bagay, pupunta siya sa region kung saan mas baba yung concentration para magkaroon ng equilibrium. In this case, in terms of acid and bases, nagpo-flow yung electrons from the base, which is highly dense electron, may siyang high electron density, nagpo-flow siya from the base to the acid, which is relatively has a lower electron density than the base. So, pag nagagawa kayo ng mga chemical reactions, hindi lang ito restricted sa acid and bases, ang tatandaan niyo lang with organic chemistry, electrons flow from region of high to low electron density. Okay? So, next slide. So, let's have here a summary naman kung ano ba talaga yung Bronson Lorry and Lewis acid. So, we discussed earlier, Bronson Lorry acid is defined to be the one that exhibits proton donation. Yun siya yung proton donor. Meanwhile, yung base ay proton acceptor. Ang limitations neto, repeat ko lang sa inyo, limitations ng Bronsted Lorry acid and bases ay nakalimit siya sa hydrogen atom. Hindi siya pwedeng mag-expand further. Meanwhile, ang Lewis acids, ang acid ay electron pair acceptor, AA, and base is a donor. So, BD. So, ibig sabihin, mas malawak ang sakop ng Lewis acid kaysa sa Bronsted Lorry acid and bases. But in the study of organic chemistry, most of them use the definition of the Bronsted Lorry acid kasi mas madaming CH na involved sa organic chemistry. Okay? Next slide. So first, we have already accomplished the first part of our lecture today. Ano ba yung mga definitions of acid and bases? So again, yung Bronsted Lorry, proton acceptor, and proton donor. Meanwhile, yung Lewis acids ay electron pair acceptor and electron pair donor. So if you have any questions, feel free to send those in the Q&A box. So let's try to answer them later, okay? So next, let's now get back to the slides. Okay, let's now proceed to the second part of our lecture. So in this part, we will have first a quantitative approach to acidity. Kailangan nyo itong maintindihan, kahit hindi yung calculation, kahit yung equations lang, kailangan nyo siya maintindihan para later on, pag nag-move forward tayo sa mga factors affecting acid and base stability and strength, para maintindihan natin siya lalo. So we have here two equations. So we have here HA, sabihin yung HA, H is the proton, A is the acid. So H acid siya. Plus water yield A minus and H3O plus. So if this is the case, we have here the chemical reaction of an acid with water. So the second part naman, we have here the equilibrium constant for acids. Let's define that as Ka. And that is equal to simply the equilibrium constant of KEQ times the concentration of water, which is actually negligible, and it is equal to the product of H3O plus concentration in the solution and the conjugate base A minus over the acid concentration. So ano ba ito sinasabi natin na to? Paano ba natin siya i-simplify? Kasi syempre mas gusto natin simplified yung mga bagay-bagay. So focus kayo sa equation natin. We have here Ka. Tanggalin niyo na yung KEQ H2O. Kahit tanggalin niyo na yan. Tanggalin niyo na sa mata niyo yung KEQ times H2O na yan. Ang titignan niyo lang dito, pag tumataas yung concentration ng H3O+, ibig sabihin yung naka-bracket, yung nasa taas, yung nasa numerator. Kung nakikita niyo yan, concentration yan ng H3O+. And at the same time, ka-equal yan ng concentration yung A-, ibig sabihin yung conjugate base. So, tatandaan niyo lang, gusto ko lang mapulot niyo dito sa slide na to, tumataas yung concentration ng acid sa solution, ibig sabihin, mas malakas yung acid natin. Ano ba yung ibig sabihin doon? Doon sa right side ng reaction, ano yung acid? H3O+. Sa left side, ano yung acid? HA. So, ano yung base sa left side? H2O. And yung base sa right side, yung A-. So, if that's the case, pag tumataas yung concentration ng acid doon sa right side of the equation, ibig sabihin, lumalakas or tumataas yung acid strength natin. I-discuss namin sila later sa inyo, bakit siya nagiging ganon in terms of structure ng mga organic compounds. But what I wanted to teach to you sa slide na to ay simply, pag tumataas yung concentration ng conjugate acid sa ating equation, tumataas din yung acidity essentially ng ating unang acid. Okay, so let's now proceed to the next slide. So this is actually yung summary ng gusto ko lang sabihin sa inyo. Strong acid, it equates to higher Ka value kasi tumataas yung concentration ng H3O+. So pag dinivide mo yon, tataas yung value ng Ka. So a stronger acid equates to higher Ka and it equates to lower pKa. Yung mga Ka kasi natin minsan, ang hirap niya i-quantify. Naka-raise siya sa mga several exponents and everything. Kaya gumagamit tayo ng pKa. Tatandaan nyo lang dito kasi hindi naman tayo masyadong magmamath when it comes to organic chemistry. A strong acid have a lower pKa. Strong acid, lower pKa, higher Ka. Strong acid, lower pKa, higher na Ka. Okay? Yun lang yung tatandaan nyo sa lahat ng equation na pinakita ko sa inyo kanina. So pag naka-encounter kayo ng questions na like, sino mas malakas na acid, titignan nyo muna yung pKa values niyo. Okay? So with that, we have an example on the next slide. So if you can see, we have here two organic compounds. And ang gusto kong i-focus muna sa inyo dito, titignan nyo lang muna sino yung merong red na mark, sino yung proton of our interest dito. Yung proton of interest natin dito, yung naka-red na highlight, okay? And the value on the right, which is the 9.0 or 9.9, siya yung tinatawag nating pKa. Okay? So, siya yung sinasabi natin on the previous slide. So, with that, sa dalawang ito, can you tell me sino ang stronger acid? Again, ang relationship natin, stronger acid equates to lower pKa. Ang given natin dito ay yung acid at yung proton at yung pKa values nila. Ang pKa value ng una ay 9.0 at ang pKa value naman ng ikalawa ay 9.9. So with that, sino ang stronger or weaker? Sino yung stronger acid in this case? Is it the first or is it the second? Can you type in dun sa chat box natin? Yung mga answers ninyo, you can guess. Or you can answer it through the chat box. Pwede yan guys, huwag kayong mahiya. Okay. Wala pang gustong mag-answer. Nahihiya pa tayo. Okay, may sumagot daw. Ang sagot ay first. Yes, that is a stronger acid kasi again, mas mababa yung pKa values niya. Okay? Yung tatandaan niya lang, stronger acid has a lower pKa but higher Ka. Okay? So if that's the case, alam natin kung paano mag-determine na ng acid strength from given na pKa values. Pero what if in the study of organic chemistry, wala tayong pKa values? Para natin malalaman kung sino yung stronger and weaker acid. So with that, I'll give the floor to Sherwin to discuss the factors affecting the acid and base strength without using the pKa values.
So, good morning. So, next slide po. So, I'll be discussing the main factors affecting acid strength. So, just so we are clear, I could write this down muna. So, there's either, you can use either naman. So, there's a good mnemonic, use ARI or ARIO, E, element, effect, or A, it's the same thing, atomic effect. R is resonance. R, resonance, resonance. Inductive effect. Inductive effect. Or O, you can use orbital. Or another hybridization, no? So just remember this, ARI. Either one, you can use either naman, ARI or ARIO. So pababa, less important factor. So ito ang pinaka-important, atomic or element effect. This is the least important. So when you're assessing the strength of an acid or a base, you always start with your first factor. Tapos kapag same sila, next ka na, next ka na, next ka na. Okay? So just remember this while we're going on to the discussion. It's also on your screen. I personally use ARI in my studies, pero you can use either naman. So next slide, please. So let's discuss the first factor. Okay. Okay. So wait lang. Okay, so anyways, as I mentioned earlier, how do we analyze the strength of acid? So Tristan mentioned, first we have to draw the conjugate base. So for example, if I have an acid, let's call the acid HA. If I want to know the strength of this acid HA, I will draw its conjugate base A minus plus H plus. I will assess this conjugate base, no? So in order to know if an acid is strong or weak, you assess the stability of your conjugate base. If your conjugate base is unstable, the conjugate base is strong. It's a strong base. If the base is strong, your acid is weak. Okay? So unstable base, strong base, weak acid. Unstable base, strong base, weak acid. If the base, your A minus, is stable, then it is a weak base. You have a strong acid. Again, stable conjugate base. It's a weak base. You have a strong acid. Stable conjugate base, weak conjugate base, strong acid. Okay? Okay. For our first, for the next slide, please. So firstly, element effect. So what do I mean by element effect? As the electronegativity of your element increases, the more it is able to stabilize yung kanyang negative charge. So as I mentioned earlier usually ganito ang general formula ng acid dissociation, diba? As I mentioned earlier. So usually, yung conjugate base mo, your A, has a negative charge, no? So if you want your A to be stable, you need an electronegative atom. So what are our electronegative atom? Usually, in organic chemistry, apat lang naman usually ang very important. So carbon, nitrogen, oxygen, fluorine. So carbon is your least electronegative, and your fluorine is your most electronegative. Fluorine most, carbon least. So which atom here is able to stabilize your negative charge most? Natural, fluorine ang pinaka-stable kapag negative. As you can see, yung data ng CH, for example, ang CH, NH, OH, at FH. if we're gonna remove one hydrogen, so that's C minus, N minus, O minus, and F minus. This is the most stable base. Most stable base. And what did we say kapag stable ang base? Kapag stable ang base, ang acid ay strong. Stable base, strong acid. So HF is the strongest acid. Does that reflect what we have in the screen? We can see that the pKa of HF is the smallest, while the pKa of CH is the highest. And it does reflect what I just said, no? So most stable base F minus, hence strongest acid CHF, which we can see from the data. So correct tayo. So element effect is our the most important factor when assessing the strength of an acid. Again, F is the most electronegative, and hence the HF bond is the most acidic. C is the least electronegative, the CH bond is the least electronegative. Okay, so next slide, please. So as I mentioned earlier, so the element effect, the identity of A, is the single most important factor in determining the acidity of the HA bond. Okay, so what we just discussed here. Okay. Next slide, please. Next slide. Next slide. Ayun, okay, so back po. Okay, here we go. So I mentioned earlier, so this is across a period. Paano pag pababa tayo ng group? So HF, HCl, HBr, and HI. So what do we learn from organic chemistry? As you go down a group, the electronegativity, what happens to electronegativity? As you go down the group, the electronegativity decreases. As you go down the group, the electronegativity decreases. But why is it that here, bakit dito, sabi nila, ito least electronegative, pero siya ang pinaka-acidic? Why is it that HI is more acidic than HF? So what we mentioned earlier, across the period, most electronegative ang pinaka-stable. Bakit kapag pagbaba, ang pinaka-stable yung least electronegative? So next slide, please. So apparently, according to scientists, now we do not look at electronegativity when we go down a group. We look at electronegativity when we go across a period. When we go down a group, we must look at size, atomic size. Why do we look at atomic size? Because when, for example, we have A minus, etong minus na to, we can think of it as a weight. As the atom grows larger, the negative charge becomes more diffuse. So it's able to carry that negative charge better than a smaller atom. So as you can see in your screen, mas diffuse ang negative charge and mas stable kapag mas malaki ang ion. No? Kapag mas malaki, increase in size, increase in stability. Increase in size, increase in stability. So down a group, we look at size, and as size increases, stability increases. And what do we say when stability increases? As stability increases, acidity also increases. Hence, this explains the trend that we see as we go down a group. Size increases, stability increases, acidity increases. As we go across a period in the periodic table, electronegativity increases, stability increases, hence acidity increases. So those are the two trends that you must look at, no? Next slide, please. So here is a small exercise. Okay, so for A, can anyone tell me which is the stronger acid? Using what we just discussed kanina, which is the stronger acid? We can look here, O at F. Can anyone answer? Sa chat. Alin dito ang stronger acid? Is it H2O or HF? HF, tama. Okay. So HF is the stronger acid. So as I mentioned earlier, you are going across a period. If you look at your periodic table, rightward siya. So most electronegative, CF, hence HF is more acidic. HF is more acidic. For B, which is the stronger acid? Clue OS. So pababa siya. You look at your periodic table, pababa ang trend. S is below O, which is the stronger acid. H2O or H2S? May sumag.
H2.
Okay, tama. H2S is the correct answer. Why H2S? Since pababa siya, we do not look at electronegativity, we look at size. Size. S is larger than O. Hence, S is able to stabilize that negative charge. You can think of it like like people. So you can think of a charge as a weight. Sinong for whom is the weight more stable? For the smaller person or the larger person? Natural, the larger person will be able to lift the weight better than the smaller person. Similar, we look at size. When you look at size, the sulfur, the larger atom, is able to lift the negative charge more than the oxygen. So here, H2S is the more stable and the more acidic. No, so correct. Next slide. Okay, so here we have the solutions, which I just mentioned earlier. So you can look for yourself at the explanation of why these answers are so. So next slide. Okay, so another set of questions for 2.15, which is the stronger acid, no? Which is the stronger acid? So so if you could answer na lang sana. Which is the stronger acid? So 2.15. For A, is it NH3, ammonia, or H2O, water? So A, B, and C. Water. Water. Tama, water. So again, we look across O, N. Alin dito ang mas right? O, HBr or HBr. Okay, tama. HBr. Why? Cl must you look at size naman. If you look at the table, there are the same group. HBr is the stronger acid. Okay, so this is a little bit more difficult. If you have a periodic table, it will come in handy. So if you look at their relative H2S, S is here. S is group, if I am correct, if I remember correctly, group 6, group 7. Ang Br is here. So group 7, firstly, in terms of electronegativity, Br is at the right of S and below siya. So at the right and below, what did we say when we go right? Increase in acidity when we go right. When we go down, increase in acidity. Increase in acidity when we go right, increase in acidity when we go left. So natural, HBr is the more acidic. So HBr ang tamang sagot dito. HB. Okay. For 2.16, which pair of isomer, which compound essentially is the stronger acid? In A, we see here, sa A, if you can imagine this, think of it as NH2. No? So Just like draw like that. That's NH2. Tapos next, the other one is CH3N. Okay. And CH2. CH2. So what are we looking at sa 2.16? What factor here are we looking at? We are looking at the H. Again, I mentioned earlier, kanina, ang C is left of N. So ang H dito is more acidic than the H here. H here is more acidic than the H here. You can kita ba? Okay. H here is more acidic than H here. And because N is to the right of C. N is to the right of C. N is to the right of C. So this one is more acidic. Okay? Okay. For the next, for 2.16b, similar case. So, we'll draw it na lang. Ganito siya. Tapos yung isa, C1, 2, 3, 3. 1, 2, 3, 4, OH. Okay. What are we looking at here naman? CH. Ganun. So, what are we looking at here? What are we comparing? Again, we're comparing element effect or atomic effect for the same thing, no? Element or atomic effect. So, ang H dito ay nakakabit sa C. Ang H dito ay nakakabit sa O. H here is in C, H here is in O. Again, we look at the period. It goes across, right. O is to the right of C. Hence, the more acidic one is this one. Acidic. O is to the right of C. The more acidic is this one. Okay? Okay. Next slide, please. Okay. So, another couple of problems. So, we'll just go through this. Which molecule is most acidic? So if you could guess. Anyone could guess A, B, or C? Alin dito ang most acidic? Looking at the element effects. Could anyone guess? No, not necessarily. B. The answer is actually B. Bakit? B. Again, you look at the elements. In A, you have 1 O. In B, you have 1 O and 1 N. And in C, you have 1 N at 2 N's. So you have 2 N's sa C. You have 1 O in A. And sa B, you have 1 O and 1 N. So natural, the answer should be B because you have 1 O, which is to the right of N, and 1 N, which is to the right of yung kanina C. So yeah, the correct answer is B. 2.18. So I'll just draw it here. 2.18. I'll draw the compound here so you can see it better. OH. N. And then H. N. H. Okay, so here's the compound. So what we're looking for is which either of this, which of these is the more acidic hydrogen? Is it O or is it N? So alin po?
Most acidic ng is H.
Which one? The H and the O or H and the N?
Ang sagot niya, most acidic.
Oh, okay, tama. Correct. Again, we look at this trend. We go across, we go to the right. O is to the right of N. So this is the most acidic. Okay, tama. So thank you for that. Okay, next slide, please. Okay, so for the next, I did not go in order, but for the next factor, we have inductive effect. So again, we have a pair of examples. We have a pair of compounds in the screen. You have ethanol and trifluoroethanol. Ethanol I'll draw it now. Ethanol looks like this. And trifluoroethanol looks like this. Trifluoroethanol. So you can visualize, no? Okay. Okay, so we are comparing this and we are comparing this. What you learned earlier is that the O connected to the H is what we should be comparing. Paso, in this case, yung O in both are the same. Pero in the data, we see that the trifluoroethanol is more acidic than this. Why is that? So where is the difference? The difference lies here. If you notice here, may tatlo tayong F. F, we know, is electronegative. In here, may tatlo tayong H. H is actually here. It's even less electronegative than your C. What happens here? So I mentioned earlier, if you want to analyze the acidity, we should analyze the conjugate base. When we remove the H here, we find that there is a negative charge at the O. There is a negative charge at the O. May negative charge siya. Ang ginagawa ng F ay pinupull niya ang negative charge from the O so that this O, kumbaga, mas magaan yung binubuhat niyang negative. Dito, the H cannot do that. The H cannot pull that charge away from the O. Because F is electronegative, it can pull the charge away from the O. H is not electronegative, therefore, it cannot pull that charge away from the O. Okay, you understand? So, yun yung that's the reason why this is more stable and this is not stable. This is unstable. And what did we say? When the conjugate base is stable, the acid is stronger. The conjugate base is stable, the acid is stronger. Why is this more stable? Because F pulls the charge away from the O. H cannot pull the charge away from the O. Only F can do it here. Okay, so that is what we call inductive effects. Inductive effect. Okay. Next slide, please. So here you can see what I'm talking about kanina. So here there is no additional electronegative atom. There is no inductive effect. The H cannot pull the negative charge away from the O. Here you can see it here. The F can pull. It is pulling the negative charge away from the O. Hence, yung O, kumbaga dito, they're the same size, they're the same everything. The O is here. Pero this one, mas mabigat, kumbaga, ang binubuhat niyang negative charge kaysa dito kasi hinihila ng F yung negative charge ng O. Okay? So this is what we call inductive effect. So next slide, please. So, inductive effect is caused by sigma bonds. What are sigma bonds? Sigma bonds are these. These are sigma bonds. They are single bonds. These are the sigma bonds. So, kumbaga, you can think of it like a circuit. These are the bonds that connect the molecule together. And the F is able to pull that negative charge towards themselves because of those sigma bonds. No? So the more electronegative atoms, the more stable the conjugate base in general. No? So we want electronegative atoms and O and F. We want them to stabilize our negative charge. So just so you know also, as I mentioned earlier, the inductive effect is caused by sigma bonds. Inductive effect, in turn, has two factors. You want your electronegative atoms to be near the negative charge. So if I were to put F here and replace that with one F, it would even be stronger yung inductive effect niya dahil mas malapit siya sa negative charge. So if you want your electronegative atom to pull stronger on your negative charge, put it near the negative charge. So you want it near and you want it more. You want more. So kumbaga, if I replace one H with, let's make all the H's F. Kapag lahat yan F, mas nagiging acidic yung compound. Why? Because there are more. Mas marami ang hinihila sa negative charge, making it even less heavy on the O. Mas magaan na ngayon ang binubuhat ng O, making the negative charge more stable. So if you want it more acidic, you want the F's, the O's, the N's, you want them near the negative charge and more. You want more of them. That makes sense if you think about it. Kapag mas malapit yung nagtutulong sa'yo, mas malapit siya sa'yo, then the weight that you're carrying is lighter because he's near. And if there are a lot of people helping you carry that weight, that makes sense because what you're carrying is now less than, for example, if isa lang yung nagtutulong sa'yo to carry the weight. So that would make sense. Okay? So next slide, please. So here is what I summarized, TLDR lang, sinabi ko kanina. So the more electronegative atom and the closer it is to the site of the negative charge, the greater the effect. So you want the electronegative atoms to be near and you want them to be many. You want many and near so that your inductive effect is increased. So it is a function of two factors, the proximity and the number of electronegative atoms or electron withdrawing groups, in general. So next slide, please, Mark. So here is a couple of problems. Number 1, 2.20. So we have A, B, and C. So firstly, which pair is the stronger acid? Which compound in each pair is the stronger acid? So here we have CH2OH and FCH2COOH. So we'll simplify. Saan ang difference? Cl versus F. Alin dito ang mas electronegative? F is the more electronegative. Hence, through inductive effect, we can know that F, the compound with F, is the more acidic. Because it's more electronegative. Okay, tama. For the second one, for B, okay. For B, I think we have to draw this. So B is Cl2. CH, CCl, CL, CH, CH2OH, CH2OH. Dito naman, it's 1, 2, 3. OH, H, CL, H. Okay, so here, we see that they have the same electronegative atom, they have the same number. Same number, same electronegative. So which one, how do we know what is the factor, what differentiates them in terms of the acidity of the OH? Which is more acidic, left or right? Left or right? Alin dito? What is the factor that differentiates them? What do you think? Left or right? Alin dito mas acidic? You could guess. Any guess? Right? No, that's incorrect. Since as I mentioned earlier, if you want higher inductive effect, you want it near and you want it more. You want your electronegative atom to be near and more. Near and more. We cannot do more since parehas lang sila ng number. Can we do near? How far is this to the negative charge here? How far is this negative charge here? 1, 2. 2 atoms, 2 atom length. This is 1 atom. This is 2 atom length. This is further from the negative charge than it is here. 1 atom lang ang distansya dito. 2 atom ang distansya dito. We want it near. So this is the more acidic. I mentioned this earlier. If you could write it down in your notebook, you want it near and you want it more. We cannot do more, it's the same number. So we want these chlorine atoms to be near the OH. So this is the more acidic. This is the more stable, this is the more acidic. And lastly, yung B, we can skip 2.20 for the sake of time. For C, alin dito ang more acidic? Is it CH3COH? Let's go ahead. CH3 COOH or O2 NO2 CH3COH. CH3 NO2 CH3 COOH. Okay. So here, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay, okay. So which here is the more acidic? Is it the left or is it right? Left or right? More acidic. So right? Right? Okay. So one of you answered right. That is correct. Why? We look at this. H versus NO2. Look at the number of electronegative atoms. You have 3. Tatlo. Here you have 0. So excuse me. So you want, I mentioned earlier, you want it near and you want it more. Near, they're the same. No, they're the same number. They're the same distance to the negative here. Same distance, 2 atom. You have 2 atom here, but you want it more. You have 3 here. You have 0 here. So this is more acidic. This is more acidic. Okay. You have 3. You have 3 negative atoms here. You have 0. 3 negative electronegative atoms. You have 0 electronegative atoms. So this is more acidic than this. Okay. Okay. Next slide, please. So for the third factor that we'll be discussing, it's resonance. Resonance effects. So when does resonance occur? When does it occur? I'm not sure if all of you have a background on chemistry already, but I'll try to explain resonance as simply as I can. So if I gave you let's make it like this. So let's call this A, B, A, and B. So if I give you the formula CH3COOH, you could draw the Lewis structure as either this or this. They're equally correct, but what is different here is that the negative charge, if you can see, the negative charge can vary from being an oxygen A or an oxygen B. In reality, the negative charge here is actually split. It resonates between 2 oxygens. So kumbaga yung negative charge here is shared between 2 oxygen atoms. It's shared between 2 oxygen atoms. Why? Because you have the presence of a pi bond. What is a pi bond? A pi bond is any double or triple bond. So here we have a double bond. This is a pi bond. And what actually happens in when you zoom in to the molecular level, what actually happens is CO. That pi bond, that double bond that I was talking about, that double bond, it is shared between two oxygen atoms. It is shared. Okay? So that negative charge is also shared between 2 oxygen atoms. Versus, for example, if I had C ganito, this is not shared between the hydrogen atoms, but it is only here, or let's make it ganito, for example. there is no sharing with the hydrogen atom because hydrogen, as we know, cannot have a pi bond. It can only have sigma bonds. So this pi bond is not resonance and it only is shared between two hydrogen atoms. But in here, we see that it is shared between two oxygen atoms. That is the concept of resonance. It is when two or more Lewis structures can be drawn for the same arrangement of atoms. And it is due to the presence of a pi bond. Here, yes, we have a pi bond, but you don't have one here because the hydrogen can only have a sigma bond. Here, you can have pi bonds with the two oxygens. Hence, it is the negative charge is shared between two oxygen atoms. Okay, so I hope that made sense. It's a bit overwhelming, but I tried to explain it as succinctly as I can. So next slide, please. Okay, so so scientists have found that acetic acid is more acidic than ethanol. Acetic acid is more acidic than ethanol. So why is that so? Let's draw their conjugate bases. Conjugate bases. Oh, this is 2 minus. Let's draw their conjugate bases. So what did I mention earlier about resonance? When this negative charge is not shared with the hydrogens here, but this negative charge is shared with the oxygen here because of resonance. So kumbaga, yung negative charge dito is carried by two atoms, while in here it is carried by one. So mas mabigat ang nafe-feel ng oxygen dito versus ang oxygen here because two oxygens are carrying that negative charge. Hence, this is more stable, and that makes this more acidic. Here, it is unstable because only one oxygen is carrying that negative charge. This is unstable, and this is not acidic. Okay? Okay. So I hope that makes sense. So next slide, please. Next slide. Okay, next slide. Okay. So as I mentioned earlier, so the negative charge is localized. It is localized to this oxygen. Hence, if I use the analogy earlier of negative charge being like weights, the oxygen carries a negative charge alone, so it's quite heavy. Versus dito, next slide please. Here, the negative charge is shared between two oxygen atoms. It's delocalized, that's a good term. Delocalized between two oxygen atoms. Hence, each oxygen atom would be carrying a relatively lighter weight than it is if it's here na localized lang siya. So this is the more stable conjugate base, which makes this the more acidic compound. Okay, next slide please. Okay, so this should be your train of thought when using resonance. Since I know it's a lot, it's for those who have no background in chemistry, it's quite overwhelming. You want more resonance as made by more possible structures, which makes the negative charge spread out more delocalization. And if the negative charge is spread out across many atoms, the more stable the conjugate base and the stronger the acid. This should be your train of thought when thinking about your resonance structures. Okay, next slide, please. Okay, so here are some problems that I prepared. So CH bond in acetone has a pKa of 19.2. Draw the true resonance conjugate for its conjugate bases, then explain why acetone is more acidic than propane. Okay, so acetone. Okay. Okay, versus propane. Propane. Okay. I'll answer this now for the sake of time. So here you have a sigma bond and you have one pi bond. This pi bond can delocalize, so it could go up. And it forms your two resonance structures. So this negative charge, kumbaga, it is shared between two atoms. Here, propane. This negative, if we remove this negative, if we remove that hydrogen, and we have the negative charge here, this negative charge there is no pi bond that could resonate with for this negative charge. Hence, we can say that the negative charge is localized to C, and this would be unstable, making this the weaker acid. And here we have resonance. This is more stable, and this is a stronger acid. Okay, next, we'll skip the next one since we don't have much of it. So next, the final criteria that we have for the strength of acid is, next slide please. Okay, next slide please. Here now, okay. Hybridization effect. So as I mentioned earlier, you could use the ARIO, atomic effects resonance in inductive and orbital or hybridization effect. So here we have some data. It shows that the triple bond C is a lot more acidic than the single bond C. So the triple bond So this is a lot more acidic than this. So that is what we see in this data. So next slide, please. I'm not sure if this has been taught to you in general chemistry, but the hybridization of this is sp3, this is sp2, and this is sp. So here we see that since there are two only, so the S character is 50% here, while the S character is 25% here. Here it is 66%, excuse me, 33% S character here. How did I get this? Since 1 and you have 3 P's, 1, 2, 3, 4. You have 1, 2, 3. So this is 1/4, 1S, and 3P. You have 1S here and 2P. This is 1/3. And you have 1S here and 1P. This is a half. So what do we see? As you increase the S character, as you increase the S character, the more acidic it gets. As you increase the S character, the more acidic it gets. Why is that so? Because atoms with high S character are able to share that negative charge more efficiently than those with lower S character. So you could see it in this trend right here. So next slide, please. So as I mentioned earlier, the more S character it is, the more willing the atom is to share electrons, and the more stabilized the negative charge is. So you could think of it as kanina din, like there are no pi bonds here, there are 2 pi bonds here. So it is more able to share that negative charge better than here, where there's only sigma bonds. Next slide, please. So as I mentioned, for the next slide, can we go back one? No, over back. Okay, so TLDR, triple bonds are more acidic than double bonds, which are more acidic than single bond. Triple bonds, single bond. So as you go up, it's more acidic. Ganun na lang. TLDR, triple bond is more acidic than single bond. Triple bonds are more acidic than single bonds. Okay, so here, a couple of problems. For A, which is the more acidic hydrogen? Is it the one with the triple bond or the one with the single bond? Okay, so the answer is correct. So the answer is the one with the triple bond. So that is the more acidic hydrogen because it has more S character And I just mentioned earlier, triple bonds are more acidic than double bonds, which are more acidic than single bonds. So for B, which is the more acidic hydrogen? Is it the one on the left or the one on the right? Okay, so thank you for answering. The more acidic hydrogen is the one on the left because it has a double bond. Double bonds are more acidic than single bond. Double bond more acidic than single bond. Okay? Next slide, please. Okay, so we'll just do A's, all the A's here. Okay, so for the first one, let's ano na lang, let's instead of ranking them, let's talk about what is the criteria that we use to rank. No, so for A, among the A, R, I, O, what is the criteria that we use to rank acidity in A? Is it atomic effect, resonance, inductive effect, or orbital? Atomic, resonance, inductive, or? Okay, thank you for answering. The correct answer is A. So as you can see, the difference only lies in the atom that is connected to your hydrogen. So atomic effect is what we use to rank here. So we use this trend to determine which is the more acidic compound. For B, what is the criterion that we use to rank this? What is the criterion? It's actually 2 per signal. Okay, so thank you for answering. That's correct. The criteria that we use to rank this set of compounds is inductive and resonance. So as you can see here, the difference between the COOH and the CH2OH, your carboxylic acid and your alcohol, is the fact that carboxylic acids have resonance. And for the one with the B, since the Br is quite far from the negative charge, we can use inductive effect to differentiate them. No? So for C, what is the criterion? So we don't have to know. Okay. Okay, thank you for answering. The correct answer is atomic. Okay, so as you can see here, the second compound, the N is actually not connected to any hydrogen. It actually looks like this, if you could see. The N is not connected to any hydrogen. It's actually the C that's connected to the hydrogen. So for the second compound, the C is connected to the hydrogen. For the last one, the O is connected to the hydrogen. And for the first one, the N is connected to the hydrogen. So we can use this trend again to determine which is the most acidic compound. So you can try this at home since we already noted which criteria to use. So 2.25, we'll just do A. So which of the following is the most acidic? THC. So if I could draw it, we'll just draw 1, 2. Okay, so I won't draw it anymore since someone answered that. So anyways, OH, the one with OH is the most acidic hydrogen. Why? Again, we look at atomic effect first. So atomic effect, OH, oxygen is the most electronegative atom, hence it is the most acidic hydrogen. So you could try the others at home for yourself. And you could message us for your answers. Next slide, please. So for the next topic, we'll be talking about the factors affecting acidity and basicity. Next slide, please. Next slide, please. So anyways, so we're going to talk about the prediction of equilibrium. As I mentioned earlier, the general formula for the dissociation of an acid, it's Ha yields H plus and A minus. So in equilibrium, the side wherein for example, the side which has the more stable compounds is more favored in equilibrium. For example, let's say that HA is a lot more stable than, A minus is a lot more stable than HA. Then that side would be more favored, and we would expect that this is a lot more dominant in our mixture than this side is. No? So, and the opposite is also true. For example, if it's ganito siya, HA plus G, for example, plus for the cation, let's say for example, HA plus is a lot more stable than HB plus. So, and we would see that this side is a lot more dominant than this side because this is unstable and we wouldn't see it naturally. So that's the general idea which we could explore in a bit more. Next slide. So how do we put this general concept in practice? So here we have some examples of some equilibrium reactions. So we have here OH minus. Oh, we have let's take for example the first one. Let's draw it. Let's draw OH minus plus what's that? OH plus beneficial. Okay. So what are we gonna look for in this equilibrium reaction? We look at the ion. Which among these ions is more stable? Using the criteria that we talked about earlier, which among these ions is more stable? And what criteria should we be using when comparing these two ions? Thank you for answering. So the correct answer is resonance. Resonance is the correct answer. Here we see that the negative charge could resonate between two atoms. Here, the negative charge is localized to one atom. So this is the more stable compound, more stable, and this is less stable. So we would expect to see more of this than this. So we could draw the equilibrium sign like this. No? So the arrow that points here is a lot larger than the arrow that points here. So we would expect in the mixture to see a lot of this and just smaller amounts of this. So correct, thank you for answering. So this is the more stable, and the equilibrium would shift towards the right. For B, this is a little bit different from what we discussed a while ago, since we're talking about cations, positive charges now. NH4. So it's a little bit different because we're talking about a positive charge. I mentioned earlier that a negative charge could be stabilized better by a more electronegative atom. The opposite is also true. A positive charge is stabilized by a less electronegative atom. Here we see that nitrogen is to the left of O, so it's less electronegative than oxygen is. So what we would expect is that the positive charge is more stabilized here than it is here. So we would see that this side is more dominant than this side. Okay, next slide, please. Okay, so here, so we're correct since the fact that this has resonance and this doesn't, this is a lot more dominant this side. So the equilibrium favors this right side than it does the left. So you could see in the screen that's correct. Since this anion is a lot more stable than this anion. Next slide, please. Similarly, since this cation is a lot more stable than this, the ammonium cation is a lot stable than the hydronium cation. The right side is favored than the left side. The right side is favored than the left side because of nitrogen being less electronegative than oxygen. Okay. Next slide. So here are some exercises. Let's just do one. Let's do the first one. Okay. So among these, which side is more stable? Is it the one with the C negative or the one with the N negative? The negative charge on the C or the negative charge on the N? Thank you for answering. So the correct answer is the negative charge on the end. That means the anion with the N negative charge is a lot more stable than the one with negative on the C, and the equilibrium shifts right or left. The equilibrium favors the right side because it has the more stable anion. So right ang shift niya. Okay? So let's do another one just so we're clear. Let's try letter D. Okay, letter D. So here again we see that the negative charge on the right side is on the oxygen, and the negative charge on the left side is on the carbon. Where is the negative charge more stable, oxygen or carbon? Is it oxygen or carbon? Oxygen. Oxygen is the negative charge is stable in the oxygen. So does the equilibrium favor right or left? Right. The equilibrium favors right because the oxygen is on the right. Negative oxygen is on the right. So that would make sense. Okay. And lastly, next slide, please. You could try this at home. Actually, let's try it now. It's just quick lang naman. So determine whether H2O would be able to protonate the acetate ion. So what does that look like? H2O plus acetate yields protonation plus OH minus. Here, this is the equation that is putting it in words essentially. So is this able to protonate this anion to make this? Is it a feasible reaction? Let's see. Which anion is more stable? The hydroxyl anion or the acetate anion? Correct. So this anion is a lot more stable than this. So we wouldn't expect this reaction to happen, but the reverse reaction would happen because this is stable and this is unstable. Unstable won't exist in nature. Stable usually exists in nature. So we would see that this reverse reaction would occur and water would not be able to protonate the acetate anion. I hope that makes sense so far. You could ask some questions if it's not clear. So next slide, please. Okay. So correct. So in the equilibrium, it would favor the left side of the reaction, which means that H2O is not a suitable proton source in this situation. So next slide. So we'll skip these na lang. You could try it at home since it's on your screen. So next slide, please. Next. Next slide. Next one. Next slide. Okay. So structural. Okay, so I'll give it next to my partner here.
Okay, hello guys. Okay pa ba kayo? I think the discussion on acid and bases really takes a lot of time kasi una, it has a lot of factors to be considered. But I hope na you're still okay there. If ever, before we start yung last part ng discussion natin, it's relatively short kasi it's an intro lang naman for organic reactions. Maybe you can stand in your seats muna and stretch for a bit. Like 30 seconds, stretch muna kayo. I think the discussion earlier is quite a bit heavy. Kasi ganun talaga eh. Pag organic chemistry, acid and bases is a lot of things. Actually, isang exam siya. So, ayun. If you're ready, okay na kayo, we can extend for a bit. Saglit lang naman itong introduction to reaction mechanisms. And if ever na G na kayo, okay, let's proceed to the discussion of introduction of organic mechanisms. So next slide, please. Okay, so una nating malaman dapat when it comes to organic reactions, ano ang nucleophile at ano yung electrophile. You can't actually do organic chemistry if you're not able to pinpoint which is the nucleophile and which is the electrophile. So if in this case, ang tatandaan lang natin, ang important thing when dealing with nucleophiles and electrophiles, nucleophiles are negatively charged molecules, negatively charged atoms, or we can simply say that they are atoms or molecules that have high electron density. Meanwhile, electrophiles, they have low electron density. From what I have taught to you earlier, like yung unang part ng ating lecture, saan ang electron flow natin? From a region of high electron density to a region of low electron density. So if that's the case, ang flow ng electron natin lagi when it comes to organic chemistry, and you need to remember this when you're doing organic chemistry, ang flow ng electrons from the nucleophile to the electrophile. Maling-mali nang gagawin natin ay galing sa electrophile pupunta sa nucleophile. That is not possible, okay? So with this slide, ang gusto ko lang matandaan ninyo, nucleophile ay negative at sa kanya nanggagaling yung electron density. Ang electron flow ay again from the nucleophile to the electrophile, N to E. Sabi, nucleophile to the electrophile. Okay? So next slide. So ayan, yung gusto ko sabihin, flow of electrons in organic chemistry is simply from a region of high electron density to a region of low electron density. Ibig sabihin, kung highly negative yung isang molecule, ay mas may tendency siyang mag-attack. Yun yung exact na term when it comes to organic chemistry textbooks. It will attack. Okay? So, pakita natin paano natin ginagawa ang electron flow. Okay? So, from earlier, we have here several organic compounds. Let's say deprotonated ethanol. Okay? So, we have here a negative charge. And let's say we have a carbocation. Okay? Carbocation. Okay? There are several examples of electrophiles and nucleophiles, and they have varying strength. However, that would take a lot more time. Sabihin, another session for us to teach yung how strong nucleophiles are and ano ba yung strong and weak nucleophiles and paano ba siyang react. But however, let's just focus here on one easy example. So again, from what I've said earlier, ano yung nucleophile? Highly negative. Ano yung electrophile? Highly positive or kaya low electron density. So ibig sabihin, for this reaction, can you see the board? Ayan. Kung nakikita nyo, nasaan yung negative charge? Nandito. So ano to? Isa siyang nucleophile. Nasaan yung positive charge? Nandito. So siya ay isang electrophile. Okay? So ibig sabihin, ang flow ng electrons at ang tinatawag natin arrow pushing, magsisimula dito sa negative charge, papunta dito sa positive charge. Ibig sabihin, ang electron flow mo, gusto mo lang ipakita from a region of high electron density to a region of low electron density. So that would result to the formation of, we have here the carbocation earlier, and we have here O and our constituent. Okay? So that's the product of the said reaction. So ibig sabihin, ito yung pinakasimpleng form ng arrow pushing. Ang arrow pushing na tinatawag sa organic chemistry, you can read those in Klein. I recommend Klein for beginner organic chemistry. Ang titignan lang natin dito, nagpo-flow yung electrons from the negative charge to the positive charge. What do you remember from your high school physics class or chemistry class? Opposite charges attract. Meanwhile, same charges repel. Are these opposite charges, the positive charge and the negative charge? Yes. So definitely, they would attract each other. So ang tendency mo, syempre yung mababa na yung electron density ko, ibibigay ko pa ba yun? Hindi na. Manggagaling electron density ko doon sa nucleophile. Okay? Take note of this example. This is a very basic principle of organic chemistry, yung arrow pushing. That's the one-step reaction. However, let's deal or exercise natin yung brain niyo for a bit. Okay? Okay. So we have here again, sote, yung compound na to. Yan. Pero let's change the nucleophile. Let's change the electrophile. We have here, we have here a ketone. This is a ketone. This is actually the structure of what? Acetone. Mga pangtanggal ng cutics. Yan, acetone siya, okay? So from this, paano a-attack yung ano muna yung electrophile and ano yung nucleophile dito? Again, the electrophile here, in this case, is this one. Bakit? Ano yung tinuro sa inyo ni Kuya Sherwin kanina? This can exist in resonance. Ano yung resonance niyan? Negative. Positive. It goes from here to this. So what? So, ba't ko siya dinrawing? Again, I just want you to see na may positive charge dito. So, ito yung electrophile. Hindi to pwede maging electrophile. So, ang gusto ko natin malaman dito, bakit natin ina-attack yan, yung compound na yan? Kasi, again, meron siyang region of low electron density. So, if that's the case, alam na natin na merong resonance yan. Okay, then what we are going to do then is to show the flow of electrons. So, you can do it in your paper, dyan sa inyo, sa tables ninyo or something. The flow of electron here, again, is from the nucleophile. It attacks this one, this carbon. Itong carbon na ito, i-attack niya yan. But again, mapupuno yan. Ma-overload yung carbon. So, yung carbon, dapat magbigay siya ng some sort of negativity sa ibang atom. Sino sasalun ng negativity? Sino yung electronegative dito? Itong oxygen. So, ang push ng electron natin towards oxygen. Okay? So, magkakaroon tayo ng compound na or intermediate na ganyan. And let's just store it like this. It's easier. Ito yung negative. Ito yung compound natin kanina. And ito yung kasama niya kanina. So, saan napupunta itong negative charge na to? Paano natin yan ini-stabilize? So, one way to stabilize it is to add an acid, HA. So, pag nagkaroon tayo ng acid dito, pwedeng i-attack, let's just add it here, HA. Okay? Pag nag-add ako ng isang acid dito, pwedeng i-attack nung negative charge ko yung proton. Again, Bronsted-Lowry acid and bases. Kaya nag-i-start talagang organic chemistry sa acid and bases. Kasi simply, ganun lang naman yung most of the reactions. And this one, kakalas yan, pupunta yan sa conjugate base. So the final product that we have, just actually quite unstable. We have here OH, and we have O, and we have that. Okay? So again, ang gusto ko lang makukuha nyo dito kasi napakadaming organic reactions, napakadaming matututunan yung organic reactions or may encounter nyo, but they are all similar in one scenario. The reactions occur from a region of high electron density to a region of low electron density. So kung na-overwhelm kayo sa tinuturo nating arrow pushing, again, you can read David Klein, organic chemistry, siya yung medyo madaling intindihin for beginners. But essentially, ang gusto lang namin i-impart sa inyo sa part na ito ng lesson ay nagpo-flow yung electrons from a region of high electron density to a region of low electron density. Okay. That's the main point of the introduction to reaction mechanisms. So let's now go back to the slides. And if you can see now the slides, we have here several reactions. When you're dealing with addition, elimination, addition, tatandaan nyo lang, add a group. Tignan nyo yung reaction. Meron akong ethylene. Meron akong methylene. Ayan. Nag-add ako. Ibig sabihin, nagkaroon ako ng certain reaction dyan, hindi ko napapakita yung mechanism sa inyo kasi medyo baka ma-confuse pa kayo. Essentially, nag-a-add lang ako ng BR at H. Ibig sabihin, tinan nyo, nadagdagan lang yung constituent ng initial kong compound. Nagdagdagan lang siya to form a new compound. So that's addition. Okay? Meanwhile, elimination, babalitarin mo naman. From the madaming constituent na compound, babawasan mo siya. So you'll have an elimination. Abstract hydrogen, then release. May masaintindihan niyo yan if ever na mag-aaral tayo ulit ng organic chemistry, we can teach you those mechanisms. But however, for now, let's now appreciate muna na ganyan nangyayari. Addition, nag-a-add ka ng group. Elimination, nag-a-abstract ka ng hydrogen. Tapos saka ka nagre-release ng halogen or yung mga bromides. So yun yung addition and elimination. And the next slide, and actually this is our last slide for today. We have here the substitution and radical reaction. So pag substitution, from the name itself, nagpapalit ka lang ng isang grupo. Nagpapalit ka lang ng, gusto mong gumawa ng alcohol, mag-add ka ng OH. Pero when you're dealing with more complex organic reactions, pwedeng mag-occur yung addition, elimination, addition, substitution, pwedeng magkaroon ng mga mga reactions. But in this case, it's a simple substitution, nagpapalit ka lang ng constituent ng iyong molecule or kaya iyong compound. And lastly, we have here radical reaction. Lagi nyo naririnig siguro yan. Yung radical. Di ba? Sabi nila, masama yung radical. Pag kumakain ka ng mga inihaw, nagpo-produce ng radical sa totoo lang. So those radical species are quite reactive and hindi nakaka-cause ng cancer. But in this case, what I want to impart sa inyo, radical reactions don't proceed in normal reaction conditions such as yung substitution, ganun. Rather, sinusuplayan natin siya ng photons or yung light energy natin para ma-break homolytically yung mga bonds natin. Okay? So if that's the case, radical reactions actually can be used to substitute or add yung mga ibang mga compounds sa ibang reactions. But again, they are quite dangerous to do. Okay, so with that, I would like to thank yung LRC then for lending us some time to use their facilities and having this lecture. So we hope that you have learned something from the definitions of acid and bases, from the factors affecting acid and bases, equilibrium positions of acid and bases, as well as some introduction to reaction mechanisms. The next time around, we can have a discussion on several reaction mechanisms, and that would be actually quite fun compared to acid and bases. So yeah. So thank you again, guys, and we hope that you have learned something for today. And don't forget yung evaluation form na isasend sa inyo. So yeah, thank you and have a good day.